Okay, class, we're about to start section 3.7, least common multiple. Section A, finding the least common multiple using multiples. A multiple of a number is the product of that number and a natural number. For example, multiples of 5 are 5, 10, 15, 20, 25, and so on. Let's compare this to the multiples of 4. We start off with 4, 8, 12, 16, 20, 24, 28, 32, 36, and so on. Notice that there are more than one common multiple of 4 and 5. They both are 20 or 40 in common, but actually they have an infinite amount of common multiples since multiples never end. However, we want the least common multiple, which is the smallest number they have in common. In this case, the number is 20. Now, one other thing you need to know about least common multiple is this here. The least common multiple, or the least multiple of a number, is the number itself. So, like here, the least multiple of 5 is 5, and the least multiple of 4 is 4. Okay, now, it says, note, we use least common multiple to represent least common multiple when writing our final answer. So, we use the LCM, which is the abbreviation for least common multiple. Now it says find the least common multiple of 8 and 10. Okay, we could do it like this. Let's do like the first 5 or 6 numbers, first 6 multiples of 8. We have 8, 16, 24, 32, 40, and let's say 48. And we'll put some dots here. Now we will do the same for 10. The first 6 multiples of 10, 10, 20, 30, 40, 50, and 60. And the least common multiple we have of these two numbers is 40. So your LCM is 40. Now we try 8 and 16. Now we already have the multiples of 8 here, so let me rewrite them again. We had 8, 16, 24, 32, 40, and 48. And of course, it could go even further than 48. Next, we have 16. We have 16, 32, 48, 64, 80, and also 96. Now, if you notice here, there are many multiples they have in common, but the least common multiple here is 16. So the LCM is 16, or least common multiple. Now we come down here to number 3. We have 6 and 10. So again, let's just go 6 places out. You have 6, 12, 18, 24, 30, 36. And we know we could go on further. Then we have our 10. We have 10, 20, 30, 40, 50, and also 60. Now, the least common multiple is 30 here, so the LCM equals 30. Now, we have 15 and 50. Let's try this again. Going 6 out, we have 15, 30, 45, 60, 75, and 90. Now we have 50. We have 50, 100, 150, 200, 250, 300, and so on. Now, if you notice, none of these numbers match up, so let's expand to 15. So it'll go to 105, 120, 135, and then next we have 150. Now we know we have 150 here, and we also have 150 here. That's the least common multiple. Now, again, there are infinite amount of multiples with these numbers, so you can keep going. So, now we look down here at section B. It says finding the LCM using prime factorization. Okay, in problem number 4 of the examples on the previous page, it took a little while writing out the different multiples until we came to the least common multiple. Using prime factorization will help finding the least common multiple for larger numbers. So what I want to do is this here. instead of going through these examples, I want to take an actual problem. Okay, now it does give you the steps, but I'm going to go through the problem to tell you these steps here. Okay, now let's take 25 and 30. The first thing we do is find the prime factorization of 25 and also 30. Now we know the prime factorization of 25 is 5 times 5. 30, we can have 5 times 6, and 6 breaks down to 2 times 3. So the prime factorization of 30 is 2 times 3 times 5, and the prime factorization of 25 is 5 times 5. Now, to build our least common multiple, I'm going to write it off to the side here. First, we're going to build it, and this is what we do. We look at these numbers as being separate. This 5 times 5 goes with the 25, and this 2, 3, and 5 goes with the 30. Now, if you notice, we have all 5s here, but we have a 2, 3, and 5 here. So the first thing we do is take the lowest number. Since this lowest number is only contained in a 30, we write it here. The next lowest is a 3. It's still only contained in a 30, so we write it down again. Now, with this 5 here, you notice we have a 5 here and we have 2 5s here. Whenever we have a number that is in both of the numbers, we see which one has the most of that number, and that's the amount of numbers that we write for our least common multiple. 30 only has 1 5, 25 has 2 5s. So we will write our 2 5s here. And now there are no other numbers, so we're done. So now we will multiply this out. 2 times 3 is 6, times 5 is 30, times 5 is 150. So your least common multiple here is 150. Now let's try this again with 15 and 50. Now I'm going to go off here to the side with these two. 15 we know breaks down to 3 times 5. 50 breaks down to 5 times 10. And 10 breaks down to 2 times 5. So our prime factorization of 15 is 3 and 5. Our prime factorization of 50 is 2 times 5 times 5. Now we look here. Our lowest number is 2. It's only contained in one of the numbers. So of course, we will write that down. So it'll be 2 times. Our next lowest number is 3. It's only contained in one of the numbers. We only write that down once. And it just so happens here that with these 5s here, we have 5 in both numbers, but this has the most amount of 5s. So we'll write those down, which are 2 5s. So our least common multiple is 2 times 3, which is 6, times 5, which is 30, times 5, which is 150. Now we know in the previous problems, all of your least common multiples is not going to be 150. Now we come here to 40 and 108. So let's take the prime factorization of 40 and the prime factorization of 108. So with 40, we know 5 times 8 is 40. 5 is prime, 8 is not. We break 8 down to 2 times 4. 2 is prime, 4 is not. We break 4 down to 2 times 2. So our prime factorization of 40 is 2 times 2 times 2 times 5. Now we go to 108. Now with 108, we could do 2 times 54. 2 is prime, 54 is not. Now with 54, we could do 2 times 27. 2 is prime, 27 is not. Now we know 27 can break down to 3 times 9. 3 is prime, 9 is not. And 9 breaks down to 3 times 3. So now our prime factorization of 108 is 2 2s and 3 3s. Now we're going to build our least common multiple. Now if you look here, now our lowest number here is 2. Now if you notice, we had 3 2s here and 2 2s here. Now remember, I told you use the one that has the most. So the most here is 3 2s. Now our next lowest number is 3. Now if you notice, we had 3 3s here and no 3s there. So we would just bring down all 3 of these 3s. And then we only have 1 5, so we bring that 5 down here. Now, we have our least common multiple. Now what we do is we will multiply this out. This will give us 41, 23, 60. This will give us 1,080. So our least common multiple here is 1080. Now just imagine if you had to write all of that out. That would have been a long problem and a long time. Okay, now I drew this line here to separate this from problem number 4. We had 3 numbers to find the least common multiple. We have 20, we have 24, and we also have 45. 20 breaks down to 2 times 10. 2 is prime, 10 is not. 10 breaks down to 2 times 5. And both of these are prime. So our prime factorization of 20 is 2 2's and a 5. Now we go to 24. 24 breaks down to 2 times 12. 2 is prime, 12 is not. 12 breaks down to 2 times 6. 2 is prime, 6 is not. And 6 breaks down to 2 times 3. So we add 2 and 3. So we will add 3 2's and a 3. And now we take care of 24. Now 45, we have 5 times 9. 5 is prime, 9 is not. And 9 breaks down to 3 times 3, and both of these 3's are prime. So we add 2 3's and a 5. Now we follow the same procedure we did in the other problems. First find our lowest number, which is 2 here. Now, the most 2's that we have is 3 2's. So we bring down 3 2's. So we're done with the 2's. Now we look here at these 3's. We have a 3 here and 2 3's here. We bring down the 2 3's because that's the most we have in one of the numbers. Okay, now we look at these 5's here. You notice we have 1 5 here and 1 5 here. So the most amount of 5's we have in one number is 1. So we will write down the 1 5. So now we will multiply this out. We have our least common multiple is equal to 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72, times 5 is 360. So your least common multiple here is 360. Now we scroll down here to section C. It says writing equivalent fractions. To add or subtract unlike fractions, we must have equivalent denominators, and one method we can use is the LCM. In other words, whatever we multiply our denominator by, we must also multiply the numerator by the same number. Now it says here, write an equivalent fraction. Now I'm going to show you a method of writing an equivalent fraction that I think would be easy to you. Okay, now what we would do here is, we notice we have across the equal sign, we have a denominator here and a denominator here. So what I would suggest that we do is this here. We would take 20 divided by 4. We'll take the larger denominator divided by the smaller denominator. So we'll say 4 goes into 25 times. We have no remainder. So what we would do with this 5 is, we will multiply this numerator and denominator by 5 to get this missing numerator. 5 times 4 is 20. 5 times 3 is 15. Now let's use this same method with the rest of these problems. So we had the same, we had denominators here. So we'll take 5 and a 15. And we know that goes 3 times. So we had no remainder. So what we're going to do is, we're going to take 3 over 3 and multiply by this 3 over 5. And that would give us 9 over 15. So our answer here would be 9. Now we do this with 56 and 8. We'll take 8 into 56, which goes 7 times. And we'll multiply 7 over 7 times 7 over 8, which will give us 49 over 56. So 49 is our answer here. Now we go down here to number 3. Now, 63 divided by 7, we know is 9. So we'll take 9 over 9 times 3 over 7, which will give us 27 over 63. And finally, we'll put a 1 under this 4 here. And we'll say, 1 goes into 6 times. So we'll take 6 over 6 times 4 over 1, which will give us 6 in our denominator and 24 in our numerator. So our answer here would be 24. And we're done with that problem. Now we start 3A, adding and subtracting unlike fractions. Section A and B, adding and subtracting unlike fractions. In order to add or subtract unlike fractions, they must have the same denominator or same bottom number. For this exercise, we will use the least common multiple method we learned in the last section. So, this is what we're about to do with this